let them play, which is great. Let them play too, let them play sports and all that. But you can also teach them something useful too around that time, all right? There was no pressure at that time also, all right? So first thing I want to talk about math is that math has no prerequisite. You can learn math at a very early age, actually. And the second thing is that math is actually foundation of a lot of STEM subjects. Everyone knows, from physics to programming to even the deep or machine learning, is all about math also. So it's one way for you to kind of pick up the subject and to form a good foundation also, all right? Another thing that's nice is that we live in the Bay Area. The Bay Area has a very large contest community also, in case you do not know, all right? So a lot of kids in the weekend, they go to maybe play baseball games and things like that. But I don't know if you know, there's a large contest community in the Bay Area. You can send your kids to, in the weekend, maybe to some kind of maybe, for example, math league contest. They have about monthly contests in the Bay Area, from elementary school, middle school, all the way to high school level. All right? It's a large community. You can see a few hundred kids there when you attend those contests in the weekend. All right? Here's another reason too why your kids should be doing math also. If you look at college admission, the AMC series to AIME, to USAMO, USAMO, and of course the IMO is the most prestigious individual national contest for college admission, bar none. Nothing else is as prestigious as math contest in general. All right? And finally, math students are also well sought after too. If your kid goes to do a math degree or do math subjects when they're in college, they are well sought after also after graduation, because math kids usually can think outside the box. They're very creative, they're very innovative. Sometimes maybe too creative, too innovative, but in general they don't think within a box. They're very smart people in general. All right? And you guys will know, right? If you go to a programming interview and all that, a lot of times they ask you some really strange questions these days, some trick questions, and they're not really about programming questions anymore. Those are actually contest math questions that they ask you sometimes. All right? Anyway, that's my opinion. You really should want to get your kids involved in math in general. All right? Here's another reason too. All right? Some of you may know about the Common Core math in this country. In general, it's considered a disaster. All right? So it's really a joke. This is a document circulating in the internet about Common Core math. All right? So here's a question. Jack used the number line below to solve 427 minus 316. Find his error. Then write a letter to Jack, telling him what he did right and what he should have done to fix his mistake. When you can simply subtract 316 by 427 to 111, there's no need to draw diagrams and all that, right? This is a well-known problem with the Common Core math problem in this country, all right? A lot of kids say, oh, I don't want to learn ahead. I just want to follow the school curriculum. Why do I have to learn something ahead of time and all that, right? But because they are not doing the job in this country, all right? By the time you learn your math subject, by the time you learn your physics subject and all that, it's already too late. It's usually the problem, all right? So for those of you who do not know this internet article about the problem of Common Core, let me urge you to search or Google for Common Core problems, and you see this article circulating up in the internet right now. All right? So later on, I'm going to tell you a little bit more about the math contest and also the math camps in the country. I have a slide here, so for now I'm just going to put them up on the board. All right. But later on, if you have questions, I'm going to ask a counselor to help us, and the counselor knows a lot better about the math camps that you should attend in this country. All right. So I'll tell you first of all the most prestigious, the holy grail of math camps that you should go to if you can. All right. And that's of course the MIT's Prime USA program, all right? Prime USA program every year takes only about 15 students of the country only, all right? In this country, all right? 15 to, someone just correct me, 19 students now, all right? And put it this way, it's actually more difficult to attend the Prime USA program than to attend MIT, actually, all right? So it's much more difficult to go to this program than to go to MIT in general, all right? But how do you get to this program, all right? So there's some prerequisite. I'll tell you later on about this. But I want to tell you other very respectable, very prestigious math summer programs you should attend to if your kids are interested in math. All right. In this area, there will be the SUMAC, run by Stanford University. All right. So they run a math camp here, very prestigious, very difficult to get in, but it's very fun, all right, for kids who like math, all right. If you do not mind going away from the Bay Area, the following 3 programs are very popular, very famous too. Probably the most famous one is Ross Math Program. This is about number theory research. All right, I don't know if you guys have heard of this program before. Very prestigious, but they are all on number theory. All right, and then 2 others, which my kids love. My kids went to Promise twice. Really like this program. They do math research there. It's called Promise. It's one in Boston, I think Boston University, and it's called Program in Math for Young Scientists. Very famous program. Kids there do research, and typically they use the research result and then apply the result to some national science fair subsequently. That's how kids subsequently won awards in science fairs like the Siemens competitions, or maybe they go to the Regen or STS. So those used to be called Intel STS research science fair. All right. So those are research-style math program run in the summer, and something I like slightly easier to get in, equally prestigious, is the Canada USA Math Camp, run on the northwest there. All right. And they may not be as prestigious as our program. Okay, it's actually very, so I just been corrected, it's actually equally competitive and prestigious also on the Canada USA Math Camp program also. Maybe easier to go to is the Hampshire College Summer Studies in Math. That's a lot easier and less famous, so we have maybe an easier chance to get into the Hampshire College Summer Studies in Math program. If you're younger, all right, and you might want to look into something like Awesome Math Camp, all right. Now this program has been not as prestigious as before. It used to be a very prestigious math program. It's not about research. Awesome Math is usually about contest math, right? And run by, I think, Tito. He used to be the head coach of IMO team in this country, all right. And he ran this program on 3 locations. I think one on the East Coast, one in Texas, and usually one in the Bay Area also. Right? So this, but they now are catering more for younger kids, so they lower the level of the studies, so it may be easier for younger kids to go to, and that will be awesome math program. All right. Of course, Bay Area also have a large contest community taking courses in STAR also, the A-STAR programs also. For obvious reasons, I won't go details of A-STAR programs. All right. So I'll tell you, if you ever want to go to PRIMES USA program, which I consider the holy grail of math research, they have certain prerequisites, certain requirements, all right? And first of all, you must be a high school junior. So you're typically in your 11th grade when you can apply to such a program. And also they ask you, where do you live? If you must be living no less than 50 miles from MIT or from Boston. Why? Because if you live closer to 50 miles, there's another program you can join at MIT. And that's called the MIT section of the PRIMES program. This one is much easier to get in compared to PRIMES USA. PRIMES USA is for the whole country. But MIT section for PRIMES is just for local Boston kids to go to. All right. And but anyway, it's not required, but usually considered preferable that you have already been a USAMO or USAMO qualifier. So how many students are qualified for USAMO or USAMO every year? About 500. So it's not that easy, but it's not requirement. So I do know they prefer that you already have attained certain level in your math contest, right? And they also require that you have done some college level course already, math courses, and they prefer that you have participation in the Canada USA this, Promise, and Ross, and SUMAC. That's why I list the 5 programs I have earlier on the slides. All right. And also, they want to have a letter of recommendation letter from a counselor, from a college professor on math also. All right. So typically, you can get those recommendation letters when you attend those math camps. All right. So that's sort of like the pathway for you to go to do math research at MIT on a high school level. All right. Anyway, if you have more questions, our counselor is here, so maybe later on you can ask her about those questions. All right. But some of you are rather young here. I want to tell you about math contest in general. All right. So math contest is not just about AMC or AIME or USAMO. There are also online contests you can go to. There are also team contests too. There are individual contests. There are also team contests also. So tonight I thought I'll bring in multiple contests on different levels and give you some information on this. All right. So the most prestigious individual contest you can attend is the AMC series. All right. I start out on AMC 8. However, there's no prestige if you go to AMC 8. All right. AMC 8 is sort of like a warm-up process only. All right. So AMC 8 is for any students up to 8th grade. All right. The only kind of honor or prestige you may have is when you get a full score, maximum score in AMC 8. That means you can answer all 25 questions correctly. All right. And but it kind of sets the stage for you, get you warm up so that you can go to the next level. The real contest starts in AMC 10 and AMC 12. All right. So for AMC 10, that means that any kids that's below up to and below 10th grade can attend. All right. And they have 2 contests every year on AMC 10 and 2 contests on AMC 12. 10A and 12A is done on the same day. 10B and 12B is done on the same day too. So you can take one. You can only take one of the 2 only on that day. All right. So most students will take maybe 10A and 10B. Some students will take 12A and 12B. But under some circumstances, you might want to take 10A and then 12B if you're so crazy. Some people actually do that. They try both. All right. But usually people will do AMC 10 twice, but they're different tests, on different days also. All right. Maybe give yourself 2 chances. All right. And they look at your score. The score determines whether you will subsequently go to the next level. The next level is called AIME, Invitational Math Examination. Each year, roughly, now don't quote me on this, I think about 5,000–6,000 people are qualified to go to AIME. It's quite an honor already to be able to go to AIME level. All right. So I'll talk about the format too. All right. Later on. All right. So you take AMC 10 or AMC 12. Hopefully that qualifies you to go to AIME, to be one of the 5,000 or 6,000 students of the country. All right. But the contest does not end there. They will look at your AIME score and they give you a composite score. The composite score is between AIME and AMC 10 that qualifies you to go to USAMO, the junior level of USA Math Olympiad. All right. So they basically take roughly about 250 students on AMC 10 and AIME and give you a composite score. The top 250 students go to USAMO. All right. They will also take the composite score from your AMC 12 and your AIME test to qualify you to go to roughly about 250 students to go to USAMO. All right. So about 250 students are qualified each year also. All right. So the composite score is taken by, I think, 10 times your score in AIME plus your score in your AMC 10 or AMC 12. Right. Now, if you do multiple tests, they automatically take your best score. If you qualify for both USAMO and USAMO, you will go to USAMO. That's how it works. All right. All right. So what do you do when you do the USAMO or USAMO test? Well, then they basically, I think there are maybe a few dozen students qualifying in the Bay Area every year, and they look at your score and then they will allow maybe a few dozen ultimately to go to a mock camp. It's called the I don't have it here. It's called the Math Olympiad summer program. All right. From within the summer program, they run a TST, team selection test, and you basically represent the country on IMO level. All right. So that's the sort of like the ultimate. That's for individual contests. So a little bit more kind of information here. If you're interested in AMC 8, all right, notice it's a 25 multiple choice questions, 40-minute test, no penalty. You can guess questions and all that, all right? So some advantage if you do well. I think your name is provided to some kind of a middle school summer camp, all right? So, but other than that, it's not very important. AMC 8 is not important. It's just for you to understand the contest format, for you to be in preparation for your AMC 10 and 12 contest. Right? So each year, maybe about 100,000 students participate in AMC 10 and AMC 12. Right? By the way, I should tell you that some college is asking you your AMC score in the college application, including some college will even ask you AIME score also. Right? So certainly an advantage if you have those scores, right? Particularly for AIME, because it has to be invited to take the test, right? So AMC 10 and 12 are different. They are a lot more serious. They have 25 questions. Usually the last 5 questions are more difficult. Right? Usually the real test is the last 5 questions of the test. 75-minute test. This is multiple choice. If you guess your answers, there's a penalty if you guess it wrong. All right. So the way it works is that I think each correct answer gives you 6 points. Each answer you leave blank gives you 1.5 points. And each wrong answer gives you nothing. So there's a penalty of guessing answers. Right? So the problems in AMC 10 and AMC 12 actually overlap. The medium hard problems in AMC 10 are the medium easier problems in AMC 12. So they actually overlap. Right? So maybe that's the reason why you cannot take both tests. Right? You can either take 10A or 12A, or you can take 10B or 12B. Some of the problems actually overlap. All right? So, like I mentioned, if you are the, you can use your AMC. They take certain number of people from your AMC contest to qualify them to go to AIME. All right. So each year, I think about 5,000 to 6,000 participants qualifies to AIME. Now, it's really a good deal. It's really an honor already if you're qualified for AIME in your maybe junior high school year or maybe in your early high school years. All right. But your goal is really to go to USAMO or USAMO on a national level, right? So AIME itself is non-trivial already. It contains about 15 problems. It's a 3-hour test, all right? So each hour you're supposed to solve roughly about 5 problems, all right? So those problems are not that easy anymore, all right? So compared to AMC, all right? So yeah, so in fact they tell you that top 5% of the AMC 12 students, roughly, will be qualified to take the AIME, and about, I think, the top 2.5% of AMC 10 qualifies you to go to AIME, roughly. All right. It's different. Each year they give you some kind of a cut-off value. Right. So, and in contest math, they really only test you on 4 subjects. All right. First of all, they don't test you on calculus. They only test you on algebra, of course it does. They are, usually we call them like algebra 2.5, a bit more than algebra 2, but it's not that crazy. All right. They also test you on geometry. They also test you on number theory. They also test you on combinatorics. All right. Combinatorics is a good thing if you want to focus or specialize on one topic. Usually combinatorics is a good area, or maybe number theory if you're interested. You know. And AIME is easy to understand. It's technically a multiple choice questions because the answers always is between 0 to 999. But it's a huge choices, right? So it's not really multiple choice. So it's easy for them to grade, but it's difficult for you to guess your answer. Or you'll be surprised. I actually know kids who can guess the answer in AIME correctly. All right. These kids are like, they really deserve to win AIME, actually. All right. So I know kids actually couldn't guess answers in AIME too. All right. All right. Yeah. So like I said, they use a composite score on your AIME plus your AMC to qualify you to either USAMO or USAMO. All right. And USAMO, of course, is really an honor in this country. All right. So I think I quoted some numbers here. Roughly in this year, out of 350,000 students, only less than 270 students qualifies for, in this case, USAMO. All right. So it's less than 1 per 1,000 students are qualified for this. Right? So college, of course, admission officers look at this very seriously. All right. But if you look also at USAMO, there's another roughly 250 students who qualifies for USAMO, the Junior Math Olympiad also. So roughly each year you have about 500 students can have this honor to go to USAMO or USAMO. Right? And quite a few of them are here in the Bay Area. Each year, a few dozen people are qualified in the Bay Area for USAMO or USAMO also. Some kids are as young as middle schoolers. They already qualified for USAMO or USAMO also. It's not early if you think, well, I'm just a sixth grader or something like that. It's just about time to start learning some math already. All right. So my kid goes to Limbrook, so Limbrook and Miller, a lot of kids there likes to do math contest math also. All right. So nothing specific here. They're very serious. In the past, usually they have a sort of like a composite cutoff to tell you when or who can go to USAMO or USAMO. This year there's some problem. There's some rumor that might have some leak or some kind of cheating going on or something like that. So they have to split the score. So this is kind of unusual for year 2017. They actually have 4 cutoffs to decide who can go to what, to go USAMO or USAMO. All right. So depend on what AIME you took, and also what 10A or 10B or top trophy that you took also. I find it interesting actually. All right. So those are about the path to go from AMC to AIME to USAMO, USAMO, and finally to IMO. But if you're on that level, you're done already. You're fine. All right. Some people do not like the pressure of doing math contests like this, because everything's determined within 1 or 2 tests that year, right? So it's a lot of pressure for kids, all right? So I want to introduce to you another kind of contest. This is called USAMS, all right? I don't know if any one of you attend USAMS, all right? USAMS is very, it's kind of obscure, but very important. Once you know who the sponsors are, it's sponsored by NSA, actually, all right? So obviously they are really, is NSA looking for mathematicians who might want to contribute to maybe encryption, decryption, and things like that. All right. So this contest is very nice because it's online. There's no time pressure. You download your contest problems. They give you 5 weeks to solve the problems. All right. So you can do anything you want. You can use computer. You can Google anything that you want. There's only one condition: you don't talk to anyone about those problems. Right? And personally, I know kids who try to write those prompts and post them on Quora and get a response. No. People in Quora know. They know what the problems are for that test, so don't do that, all right? So I've seen that. In fact, I'm one of those Yale students who try to post prompts on Quora on all those USAMS problems. Sorry. So USAMS problems are like this. One of the things I want to encourage everyone to do the USAMS is that USAMS is how you hone your skills in writing proofs. So a lot of people do not realize that. When you do your AMC path, it qualifies you to go to AIME, it qualifies you to go USAMO or USAMO. You have a problem, all right? It's like they're trying to run maybe a field and track event on sprinters. But whoever wins the sprinting event, let me promote you to marathon event. That's crazy. All right, these countries they use a very strange approach to pick students to go to the IMO camp, right? They pick the sprinters, which are people who do who do the AIME, who do the AMC and all. Those are sprinters. They're very fast. You'll be amazed how fast those kids are, right? Some of you here probably already on that level, right? But then they throw you at a USAMO or USAMO contest. So there you solve like 3 problems in 4.5 hours. Speed does not give you any advantage anymore, all right? And a lot of kids do not even know how to write proof problems. That's sad, all right? So to hone your skills, you take the contest in USAMS. USAMS are proof problems. Does it make sense? All right. So each problem is except for problem number 1. Problem 2 to 5 are proof problems. All right. In fact, a lot of kids say, "Oh, I got my problems right already." And I know a lot of kids. They went to USAMO or USAMO. They said, "I got problems right. I expect myself to so and so score." They come with a 0. They don't know how to write proofs actually. All right. To hone your skills, take the USAMS test. Does it make sense? All right. So also USAMs are the right level too. Plus you have lots of time. You're not under pressure. You don't have to solve the problem in 1.5 hours, for example. All right. So here's one thing too. That's a back door too. USAMs is a back door. It's that I cannot do well enough on AMC 10 or 12. I really want to go to AIME. Well, then take USAMs. USAMs can also qualify you to go to AIME also. Very unknown back door to take AIME actually. All right. So in other words, if you do well on USAMs, you can also be invited to AIME also. All right. Very few people know this track. You can actually take AIME by taking USAMs also. Right? But having said that, I should tell you that your USAMs ones are not easy. If they give you 5 weeks to solve 5 problems, right? That's not your standard Algebra 1 problems, right? Obviously. All right. Now, so those are individual contests, right? Some of you like to join team contests, right? Hey, because if I do not win well, maybe my team will win some national champion for me, right? And that's the case, in case you do not know. Bay Area is almost the kind of unqualified champion of the country for AMO. All right. So I think we win, what, 3 out of 4 years for first place of the country? First place of the country, right? So for those of you who don't know about AMO, AMO stands for the American Regional Math League. That's considered the World Series of Mathematics Contest. They run the contest in 4 satellite centers. They link them up with satellites. I think at University of Iowa, Penn State, Las Vegas, and the University of Georgia. They link them up, run the contest at the same time. So each region picks 15 students to attend the contest, but not San Francisco Bay Area. I think we have at least 7 or 8 teams or something like that. Yeah. So I don't know. They have to, because so many students want to attend the contest, right? So what's your goal? Join team A1, right? Because they pick the score. They pick your score and put them together in the same team, right? So I don't know how many teams they form every year, and they go to Las Vegas. They usually take a bus or fly to Las Vegas and do the contest, right? And it's a very nice community too. That's the fact that you form bonds and friendship with team members and all for years. Right? These are same kids who subsequently go to MIT, to go to Harvard, to go to Stanford together. Right? All right. So universities hold math contests too. So I thought I'll bring in a few of those most prestigious math tournaments run by universities then. All right. So probably the most important one, the most famous one is HMMT, Harvard MIT Math Tournament. Right? So of course it's run in Harvard or MIT. They take turns to host the contest every other year. Right? Princeton runs something like that too, called Princeton University Math Competition. And I believe on the same day they also run a physics contest. So you make up your mind, do you do the math contest or physics contest that year? Right? So I don't think you have time to take both. Right? In California, you would take the, I think Caltech and Harvey Mudd runs their own math competitions. In Southern California, you go to Pasadena area, or Southern California. In the Bay Area, Berkeley runs the, I think it's called Berkeley Math Tournament, BMT. All right. Some of these contests are different than regular math contests because they might test you on calculus. So not just on the number theory, and they have contests on calculus mostly. Stanford used to run some math contests. I don't think they do anymore. So for some reason they don't want to do math contests anymore. So no math contest from Stanford University. Right? Hey, but maybe your kid goes to Stanford, he can decide to run the math contest again in Stanford. Right? Anyway, so I thought I mention something about the math contest in this country. So I thought we have time, so I thought maybe I'll bring in some courses we run at Springlight. But more importantly, I want to tell you what those courses are about. All right. So some parents actually are not quite familiar with all the classes that your kids are taking. What classes will be needed for them to do math contests, or maybe to do math research in general. Right. So I thought I'd bring in some information about the classes. We happen to be teaching some classes also in Springlight. Right? So I thought I'll bring in some of the, yeah. So this fall we're running a few courses. There might be more, there might be few, I don't know. But I want to show you what classes will be like if you are interested in maybe taking AMC 8, maybe you want to be prepared for AMC 10 or 12, maybe you want to learn pre-cal or calculus ahead of time or something like that. Some courses you can hear. So like I said, if you do contest math, they really only ask you topics like algebra, combinatorics, number theory, and geometry. So the start, I'm going to give you a few examples, what kind of problems they ask you, what kind of topics we cover in our courses here to illustrate. So maybe about algebra. Alright. So they have some funny thing called a nested square root. Maybe you cannot see that, huh? This is the infinite square root. Dot here. So what's the value, that kind of stuff. Alright. So don't worry, I'm not going to solve the problems. I just want to tell you what kind of. Maybe turn off the lights. It's pretty difficult to see, huh? So I should tell you, this is square root sign. Adding square root, just nested square root, and it goes to infinity.
Yeah. Will you be sending the slides out later?
I will upload to the Spotlight's website.
Right, that would be great. That way we don't have to take pictures.
So this is kind of one of those kind of problems they'll ask you. For example, is this the right level to learn this kind of stuff? So maybe a contiguous fractions. Right. So what is, you cannot see again, this is 1 over 2 plus 1 over 2 plus 1 over, and it go to infinity. So what's this? So usually you solve it like algebra, actually, in case you do not realize. So you set x equals to this, so therefore x equals to 1 over 2 plus 6, you can solve for this kind of stuff. Don't worry, I'm not teaching math here. I'm going to show you what style of problems they may ask. All right. So this is a common combinatorics problems. If you ever visited like New York City, you know the city is arranged like a grid, right? So, and so suppose I'm at point A here. I want to go to point B there. How many paths are there for me to go from point A to point B? It's a standard question in combinatorics. Right? So there are many ways to solve them. You can think that, well, I have a bunch of letters here. U, right? For example, U. So that's how I go from point A to point B, right? If I mix this letter, how many ways are there for me to permute these 7 letters? That should be an answer, right? So answer will therefore be 7 factorial over 4 factorial divided by 3 factorial, right? That's one way to think, right? Another way to think is that, oh, maybe I have 7 slots here. 1, 2, 3, 4, 5, 6, 7. Let me pick 3 of them. The 3 slots allow me to put an up arrow there. So maybe I pick up arrow here, here, and here, here, and here. That means this is my business. So, well, I don't have a marker. I have 7 slots here. I pick 3 slots where I put my up arrow. So the answer should be 7 choose 3. That's one of the paths I can go to from point A to point B, right? So that's another way to think about this kind of problem. But some of the AMC problems cannot be solved as easily, right? So sometimes people actually count the paths, all right? So this is one way to do it too, all right? So I want to go from this point A here to point B here. The answer is 35, by the way, all right? So how do I come up with that conclusion? There's only one way for me to walk from here to here. One way for me to walk from here to here, etc. So all you put up ones here. But there are 2 ways for me to walk to this point here. I can walk here, I can walk here. So the number 2 here is by adding this to this. Right. What about here? Well, I have 2 ways to get to here, 1 way to get to here, there was 3 ways for me to get to here. Makes sense, right? So on and so forth. If you add them all up, you notice there are 35 ways for you to come. So you may think, oh, why would I want to do something so elaborate? All right. One of the problems like this a few years ago in AMC 12 or AMC 10 must be solved in this manner. So I won't go through details. All right. So in AMC 8, we also teach our kids about something called sticks and stones. All right. This is another problem that's very common. All right. So you appreciate this problem too once you understand this example. All right. Suppose you're ordering half a dozen donuts. I want to buy 6 donuts, all right? There are different flavors on the donuts: glaze, powdered, cream filled and jelly filled. All right. So maybe I can buy 2 glazed, 1 powdered, 3 cream filled, and 0 jelly filled. That's one way to buy the donuts. Make sense, right? Or maybe I can buy 5 glazed, 0 powdered, 0 cream filled, and 1 jelly filled. That's 6 donuts. How many ways are there for you to buy the donuts? Right? So you must be kidding if you want to do kind of like casework. Right? You don't do casework, right? You need to learn something called sticks and stones. All right. So don't worry, I won't teach math here. We are not doing a math class right now. I just want to tell you the way people think is that it's okay. You have 4 flavors. So let me bring everyone to the beach then. All right. Let's go to the beach. Let me lay down 3 sticks on the sand. So I separate the region into 4 regions. Let me bring up 6 stones that float them up in air, and let the stones settle on your sand. All right. If I see 2 stones on one side of the stick, and one stone between the 2 sticks, etc. This is how I distribute my 6 donuts into 4 types of flavors. That will be one solution. So the number of ways you can buy your donuts will therefore be 3 sticks plus 6 stones, that means 9, and I choose any 3 positions to move my sticks. So answer will be 9, choose 3. All right, so the answer is 84. All right, so you cannot do casework on a problem like this. It will take you way too long to do this kind of problem. Again, I'm not teaching math here, so we'll show you how problems we teach in AIME 8. Also, they will ask you probability problems, just even on AIME 8 level, all right? There are 2 ways to look at probability problem, all right? You can do compound events, different probability, add them, subtract, add them, maybe do complement probability, etc. Or you can do combinatorics. So usually when we teach probability, we use either compound events or we use counting techniques to do so, all right? So for example, let me give everyone a very simple example to illustrate the concept, all right? I have 4 green blocks, 3 red blocks in a bag, and I want what's the probability that I select 2 red blocks without replacement. All right. So one way you can say, well, you don't replace. So the first pick will be 3 out of 7 red blocks. The second pick will be 2 out of 6. Why 6? Because I don't replace them. Why 2? Because I don't replace them. Right. That's the probability that I get a 2 red blocks. Right. This is what I call compound events. First pick and then second pick. Right. But you can think of it as a counting techniques too, right? So you don't replace the blocks, fine. I go inside your bag, out of the 3 red blocks, I get 2. So I get 3 choose 2 or 3 ways to pick the 2 red blocks, right? But I totally have 7 blocks. So the total number of ways I can pick 2 blocks out of 7 will be 7 choose 2. So the probability will therefore be 3 divided by 20. Same answer, of course, right? So some kids are different. Some kids like to do counting. Some kids like to do compound events. It all depends. So we usually teach them both. See what fits them better. All right. I won't go through other problems. The other problems about different approaches to do probability. Like I said, I'm not teaching math this evening, so don't worry. Problem number theories. All right. These are the classic problems. I have a number 56 there. They might ask you, so how many factors does 56 have? 1, 2, 4. No, you don't count like this, all right? What you do, you actually, well, if you want to, that's okay. But usually you factorize them, all right? So this is called fundamental theorem of arithmetic. Any number can be uniquely be factorized into prime factors. You cannot see that, but 240 equals to, I think, 2 to the 4 times 3 to the 1 times 5 to the 1, all right? Then the total number of factors you have is just 4 plus 1 times 1 plus 1 times 1 plus 1. It's a well-known trick that contest math students will know. All right. The reason that's the case is that, well, I have 4 factors for 2. I can use none of them, 1 of them, 2, 3, or 4. There are 5 choices that I have, right? There's only 1 factor of 3 here. I don't have to use it, or I use it once. There are 2 choices. Same for these 5, 2 choices. So answer is 5 times 2 times 2. We also teach the kids on the base representation of a number. So they might ask you, how do you convert 228 base 8 to base 4? All right. So if you look at standard textbook, they will usually convert the number 228 in base 8 into decimal value, and then they convert decimal number back to base 4. Yeah, it will always work. All right. But there are tricks though, you should know. If you have 228 in base 8, you can actually group them in groups of 3. For those of you who know this kind of trick, so 2 is written as 0, 1, 0, 2 is written as 0, 1, 0, 2 is written as 0, 1, 0. This is the actual representation in base 2 in that representation. Right? Then when you want to change it back to group base 4, you group them 2 at a time. So group them 2 at a time, here, 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 and you convert them to base 4. So that will be 0, 2, 1, 0, 2. So it's the same value, much faster if you know this kind of trick. Right? It works for base 2, base 4, base 8, base 16. It also works for base 3, base 9, base 27, etc. Right? Here's another question, all right, just for AMC 8 on number theory. So they give you some big numbers. Sorry, I cannot read them well. I can read them on the slides. What is the last digit, the unit digit for 652 raised to the power 39? What's the unit digit for 983 raised to the power 61? Or 777 raised to the power 102? 588 raised to the power 777. Obviously, you do not multiply them and look for the unit digit, right? So you look for patterns, right? So you look for this digit here, how long does it repeat itself? And then you do the modulus or remainder, dividing this number with that period. That's how you know what's the unit digit. So in AMCA, we talk about this kind of problems already. Right? So I won't go through details. You also go to formal training of discussion on modular arithmetic. All right. And of course, geometry. All right. For younger kids or AMCA, it's one of the difficulties. Some kids have not learned geometry before, all right, and they have to do AMC8 already. So we teach kids also on geometry. Also, for example, we talk about this is on angle tracing, all right. So this is the angle measures A here. That means that if you look at the angle here, that will be A over 2. If this arc is measured, the angle measures B, that means the angle here is A over 2. That means that any angle here will just be the sum of the half of the angle measure on the arc. Right? So this kind of angle chasing we teach the kids. And of course, if you look at similar triangle, of course you recognize this angle equal to this angle equal to this angle equal to this angle. So this triangle is similar to this triangle, and therefore this time this equals to this time this. This is called intercepting chord theory. Some people call it a power of a point, right? For those of you who do this kind of thing. Anyway, that's about AMC8, all right? So I think I mentioned earlier, the real contest rate comes in when you do AMC10, all right? AMC10, so these are some of the topics that are very common, all right? So yeah, in fact, there's something called pigeonholes also, so those of you who know this kind of stuff. All right, so these are maybe questions they may ask you. All right, so have a little polynomial expansion. They ask you what's coefficient x7 in the expansion of this. And of course, you are not supposed to just expand this by hand. Too slow, right? So what do? So there are many approaches. One approach is this. You write this as this plus this, and you expand this sort of as a binomial expansion. All right, so you have a bunch of terms here. Now hold on, they're looking for coefficient x7, but this term here, the highest term is only x4. So you don't have to look at this term already, right? The highest term you have here is x to the 3, and x squared, so x5 only, you ignore this term also. The highest term here is square, plus 4, 6, or you ignore this term here. This term is x8, so only term you have is here. It makes sense, right? So therefore you see x6, that's the coefficient of x7, that will be 4 times 2 times minus 1 is minus 8. Makes sense, right? So they ask your kid to be very creative when it comes down to this kind of problem, right? All right, they ask you a lot about functional equation. All right, so there's a little functional equation, fx plus 2f1 of x equals to 3x. They ask you how many non-zero solutions are there for the equation fx equals to f minus equals f minus x, right? So this is ugly. Functional equation should not be ugly, so you get rid of the ugly part, all right? So you can substitute anything into this. So put 1 over x here, from which you get the fx actually is this. Once you know what fx is, it's trivial. Make sense? All right. Lots of questions on functional equations in MC Chem. And they ask you something about maybe similar triangles or geometry. All right. So this, in fact, this is some kind of older AMC 10 and 12 problems. All right. So they give you this a rectangle, dimensions are known, and they ask you what is the height or area of ABB here. All right. Well, obviously, if I know the height, I'm done. All right. And the length here is 2 to 5. So the ratio of here to here will be 2 to 5. And therefore, the height of here to here will be 2 to 5. I know this. If I set this to h, I can solve for h. That's how you know the height. Make sense, right? So they're not so obvious, but you're transferring the similar triangles ratio from one triangle, from this ratio to this, from this to the height. Make sense, right? So you went through 2 sets of similar triangles. And sometimes they're very nasty. They're very a bit difficult too, all right? So they have a circle here inscribed inside 2 arcs here. And looks like this is an equilateral triangle, like this. They ask you what's the circumference of this circle. It's not an easy problem, all right? And the solution lies in the fact that, and kids have to recognize the fact that whenever you draw circles touching one another, you immediately draw a line between the centers of the circles, because that line will intersect at the tangential point where the 2 circles touch. So this is a straight line. Does that make sense, right? And the length here with the difference of the two radius. Does that make sense, right? This should be like a knee-jerk reaction. You see it down, you draw the line already. All right. So you know this is big R minus small r here. All right. So this is small r. This is big R. All right. So and then this is R. So this is big. This is just R. So you know this little right triangle here. You can solve for big R. You solve for everything. Except that where do I know big R? Well, they told you what this is. You know the arc length here is 12. You know this is 60 degrees, so you know R. Make sense? This is much easier. All right. In fact, they try to help you. All right. There are 2 squares here, A, B, C, D, and C, H, E, F here. What's the area of the region covered by the unions of these 2 squares? What's this area together? All right. So it's a what the? They don't even give me the angle of rotation. Oh, they don't give you that. They try to help you. That means irrelevant, independent of the angle of rotation. All right. So why is that the case? If you look carefully here, the area here, this area here is the same as this area here. So it doesn't matter. You can rotate back to 90 degrees. You can rotate this to 90 degrees. Then anyone, my mother included, can solve the problem immediately, right? So sometimes it's very easy, right? Now this is a classic problem a few years ago, and on combinatorics, all right, can be very nasty. So they tell you there's a spider. The spider has 8 legs, and the spider wants to put on socks and shoes one day, all right? So that means there will be 8 socks and 8 shoes. All right. Now there's a rule though. You only put the socks first, then you put the shoes on. That makes sense, right? And so they ask you how many ways or how many different orders can the spider put on the socks and the shoes, right? Now this doesn't sound like an easy problem, right? It's actually not that difficult. All right. So one more time. So 8 legs, and each leg can put on socks first and then put the shoes on, right? So if you suppose there's no constraint, you can put on your shoes and your socks anytime you want. Then the number of orders you have will be 16 factorial. You have 16 symbols. Make sense, right? But because there's 6, I think the author used S1 as the shoes symbol and lowercase s1 to be the socks symbol. So I put on socks and then put on shoes, right? Now, so if there are no constraint, if I can put on shoes before my socks, if I put on socks before the shoes, then there will be 16 factorial ways, right? However, out of those ways there, some of them are not allowed. For example, just look at one leg, leg number 5. I must first put on the socks and then the shoe. If I put the shoes first and the socks later, it's not allowed. So for leg number 5, my answer must be reduced by factor of 2. Does that make sense, right? And there are how many legs? There are 8 legs, right? So answer must be reduced from 16 factorial to 2 to 8. Make sense, right? So sounds extremely difficult. It's actually not. So this is another problem. I like this on probability. So the problems are very creative, right? They tell you to have a die, like a dice, and the dot is removed randomly. So there are 21 dots on my dice. So one of the dot will disappear magically. All right. Now I roll the dice. What's the probability the face has an odd number of dots? That sounds not trivial problem too. All these are non-standard in programming context, right? So one more time, I have a dice. The dice face are 1, 2, 3, 4, 5, 6, right? One of those will suddenly disappear. If I roll the dice, the face that shows, what's the probability that the face that shows up has an odd number of dots? All right, wow, that is not trivial, right? So there are two ways the way to think about this is that there are really only 2 cases. First of all, maybe I roll, suppose I roll a value of 2, the face 2, all right? So if face 2 shows up and the answer is odd number, then if face 2 shows up and at that time the face has 1 dot disappear, that's how I get the odd number on the face, right? So for face 2 to show up, the probability is 1/6, and face 2 has 2 dots. Out of 2/21 probability, it will going to lose a dot for his face. So that's the probability for face 2 to show up, and at that time, face 2 also lose 1 dot. All right. This is probably for face 4 to show up, and one of the 4 dots lose itself. Make sense, right? This is probably for face 6 to show up, and one of the 6 dots lose its own dot also, right? Or maybe face 1 show up. This is probably face 1 show up, and face 1 is an odd number. So if you do not lose your dots, other people lose the dots, then your face will show as an odd number. So the other dots are lost will be 20/21. This is for face 3 to show up, the other dots are lost themselves, not this face. For face 5 to show up, the other 16 dots lose one of them, not the dots on the face 5. Right? Sum them together, that's the probability. Right? Certainly not a kind of a standard problem in your textbook. Right? They ask you questions on number theory too. All right? This is more modulus arithmetic. All right? One of those earlier problems. 5/7 equals to A2/2 factorial plus A3/3 factorial, etc. All right, and you are told that A2 through A7 are unique integers. What are they? What's the sum of these integers there? All right. Don't worry, I won't go through all the details. It's going to tell you this is a sort of like a standard modulus arithmetic problem. So what you do, you multiply everything by 7 factorial. So you get something like this. Now, as Alpha Benjamin will tell you, put on your glasses about modulus arithmetic, you see that this is 0. It's divisible by 7. This is divisible by 7, by 7, by 7, by 7. So you put on glasses, which only sees the remainder. If every number is divided by 7, this has a remainder. This is the answer will be 7. So remove all these terms here, and just look at this modulus 7, that would be A7. Make sense, right? You repeat the process and solve other numbers too. I won't go through the details. So, and they ask you series or sequence problems. This is a sequence problems. A1, etc. is a sequence of numbers. A1 is 1, A2n equals to n times an. What is A2 to the power 100? For these kind of problems, there are 2 ways to solve them. You can build up the solution, or you can break down a higher term into lower terms. All right. I prefer to break it down. Some kids like to actually build up the solution. The official answer is to B of the solution. You can equally well breaking down the number with smaller terms or earlier numbers in the sequence. All right. I also want to show you guys this slide because to tell you a lot of times, and I find it amazing, even the AMC 10, AMC 12, a lot of times you actually use something as simple as cosine formula to solve problems, right, which you may not expect. All right. So this is one of those problems in AMC 12. It's a high number problem too. All right. So the simply asks you what is the value of 2x. All right. It's totally not expected that you use a humble cosine formula to solve. All right. So you use this angle and look at this triangle and this triangle to set the two relationships on which you can solve for 2x. Right. Now this problem is very common. I've seen it met multiple times already in AMC, and this problem is almost always of this form. They give you some kind of a 3D structure and ask you what is the height or altitude by dropping from D to this plane here, ABC. You see that? ABC is a plane. They ask you if you drop a perpendicular line from D to this plane, what's the value? Happened so many times already. All right. The solution is very simple. It's to calculate the volume in two different formats. All right. You see the volume here of this solid here. You know the height. You know this triangle here. So you know volume here, right? All right. Do you know the area of this triangle? Therefore, you know the height dropping from D to that space. Right? Happens all the time. All right. So you have to know, right? Not just AMC 10, and it happens everywhere. In fact, including like even some maybe some SAT subject tests also. It's the only problem they can ask you in a lot of sense, right? It's a very common question. All right. And they ask you things like log functions. I won't go into details. And you're supposed to know the Morpheus theorem for those of you who play with complex numbers. All right. So this is based on Euler's formula. That you don't a lot of times you find it very convenient to use polar coordinates, the polar format of the complex numbers, right? So represent your complex number as a magnitude times the e to the I theta, where theta is the angle of your number. So I thought I'd bring you one of the problems in AMC 12 about how to use the Morpheus formula to solve for the questions. I won't go into details. Right? So then I also want to talk about what you learn in pre-cal and calculus in general. All right. So the material we use is spring light. They are rather standard, and this material is actually very good. And the pre-calculus part covers most everything that you need, including something that might be beyond the standard pre-cal curriculum. All right. So for those of you who do not know what pre-cal is all about, a lot of times they ask you to sketch those functions, maybe from rational functions. So the way to solve this is you need to know the asymptotes, behavior at infinity, and also, of course, your intercepts. But most importantly, you need to know where your oblique asymptotes are, what your vertical asymptotes are also. So I won't go into details. They go through do you have any horizontal asymptotes? Any oblique asymptotes? Do you have any intercepts? What are your behavior of the function in infinity? And zeros, and also, so then they graph. Right? So common scenario, some common knowledge you learn from pre-calculus. Right? Of course, you learn what we call the conic sections, the circles, parabolas, ellipses, and hyperbolas. I won't go through any of the details now, right? In pre-cal, it depends on your teacher. Some teacher already talk a little bit about differentiation already, so you can do optimization of your functions. It all depends on your teacher, all right? So they use what they call first derivative test and second derivative test to look for what they call the global and local minimum or maximum. And of course, one of the most important topics or skill sets you have to pick up in pre-cal is to learn how to do trigonometry, including angles more than 90 degrees, right? So what they do is they do what we call reference angles. So you look at angle that goes beyond 90 degrees, and what you do is you look at that angle with respect to the x-axis, from which you calculate what they call a reference angle, and then you give yourself a sign. Sign may be positive, may be negative, based on what quadrant your angle falls in. Another topic you want to learn well in pre-cal is on, of course, all this compound angle formula, sum of angles, difference of angles, sums and products, etc. Right? So this is something you have to know in pre-cal, and from which you should also acquire the knowledge to be able to solve like common trigonometry questions. Right? So some students find it difficult to understand this. How you solve this? 3 sine 2x equals to 1, and x can go between 0 to 2 pi. A lot of people miss out the point that this is not just x, it's 2x, right? So when you solve for the angles there, first of all, there are 2 angles, 2 quadrant, on which you have in 360 degrees, 2 quadrant, right? So one quadrant is in, let me see if I can write a little down here. So here they ask for solving sine 2x equals 1/3. The sine is positive in 2 quadrants. We call it CAST rules, C-A-S-T. It can be positive here, it can be positive here also, right? So there are 2 quadrants in which you can have 1/3, all right? So one is here, so this is your angle, the other one is here, this angle. In either case, this is your reference angle, all right? So you have to write your answer into a form of 2 pi k, because this angle is the same if you rotate it by 2 pi. If you rotate this angle by 2 pi, it's still the same angle. So in general, you write plus 2k pi there, all right? Why do you have to do this? Because because you say 2x equals to this, you solve for x, not x, and then you substitute different values of k here to see when do the angle fall within this range. That will be your answer. A lot of students miss out on that step. All right? Notice that we have to substitute k equal -1 or 2 to get to some, well, these are too large. 1, or you have something k with 0 to get some one of the values. So you never know. Particularly when this angle is large, maybe multiplies 3 or 4, then you really do not know what k to use. You have to try it. All right? In pre-cal, that's where we learn the De Morphus theorem. So any complex number can be written as in a polar format, magnitudes to power n times cis. Cis is cosine theta, n theta plus I sine theta, n theta. All right. This really speeds up your computation in complex numbers. And some kids also are very interested in also learning how to do linear algebra. All right. So in fact, I find it sometimes surprising. I tutor quite a lot of kids. I realize some kids do not know how to handle a n by n determinant. All right. For some reason, it's not taught in school. For some reason. N by n determinant is done by actually asking you to expand either by row expansion or column expansion. You pick a particular row or column, maybe here. All right. So then, let's say the author picks this row here. So when you pick a row here, you hide this, and you see this little smaller determinant here. All right. So you have a1 times this times a factor. The factor is actually -1. To power 1 plus 1, because this is considered A11, 1 plus 1. And then when you go to A2, you hide this row, you hide this column. This is the determinant you see, B1, B3, C1, C3. So this is actually plus A2 times this, multiplied with -1, 1 plus 2, because this element is considered 1, 2 element, right? And so on, right? So you can reduce a 3 by 3 determinant into a 2 by 2 determinant, etc. So in general, if you have an n by n determinant, you can break it down to n-1 times n-1 determinant. Seems perfect if you're doing programming. That's how you write, if you want to, that's how you resolve a determinant into a scalar value. And of course, in pre-cal, you also learn maybe binomial expansion. Now, one thing you notice that though, these topics are really the same topics that you could have leverage on in math contests, right? So here's the difference. Contest kids learn this a lot earlier and they use it like their little tool set, all right? Whereas in high school, usually you have to wait until pre-cal to learn this kind of subject, right? The difference is that contest math kids, you should know this technique already because they help them in the contest themselves, right? So if you talk to any contest kids, of course they know binomial expansion, right? So this is typically considered a standard subject in pre-cal, right? Over Cal. Some people ask me what's the difference between Cal, should we take AP Calculus AB, should we take AP Calculus BC and all that. Usually, the recommendation is that you should take AP Calculus BC, right? For many reasons. First, colleges value Calculus BC a lot more than Calculus AB in general. B is a lot easier to get a 5 in BC compared to AB, all right? And what's the real difference between AB and BC? Well, do they ask you to do convergence tests? Do you have to do the Taylor series expansions? That's the difference between BC and AB. So I usually recommend our customers that you should really be thinking serious about taking Calculus BC. Unless you have other valid reasons, you should be taking Calculus BC. Right? So I'll show you a few slides about what we do in our Calculus BC class in Spring Lake. All right. So we talk about things like limits, and we look at sandwich theorem. Of course, we talk about definition of derivative in calculus classes. We learn the chain rules. We do product rules. One of the very useful technique that kids should pick up, including if you go to a math contest in calculus, all right, is learn well about your implicit differentiation, all right. So a lot of times when someone gives you this kind of equation, and all you want to know is what's the dy by dx, all right. A lot of people will struggle to try to express this y in terms of x and then do your differentiation. You don't have to. I call this like a blender approach. Flow everything in your blender and grind it, all right, at the same time, all right. This is called implicit differentiation, all right. You can actually differentiate this without writing explicitly y in terms of x. All right. Of course, one of the main purposes of doing calculus is to do optimization problem. So of course we talk about your local and your global extrema, be it minimum or maximum, throughout the process. And then when it comes down to the antiderivative or the integration part, there are actually two ways to look at it. All right. When you look at calculus integration, there are two ways to look at it. One is what we call indefinite integral. That means I'm simply doing an antiderivative. I know the function. I want to go back from where it was from. All right. Another way to look at it is, oh no. Integration is about calculating the area under the curve. That's what we call a definite integral. That's called a Riemann sum. All right. So in calculus, we show you that these are the same definition. All right. Indefinite integral, its definition is really the same as the Riemann sum definition for your definite integral. All right. And then we do all this kind of integration process. And of course, this is the Riemann sum. And we prove it through the second fundamental theorem of calculus. And of course, we apply them. Right. So in a typical calculus classes, we'll use typically maybe this method, washer method, or what we call a shell method to calculate the volume and maybe the circumference and area and things like that. Make sense, right? And it's very easy. It's directly applicable. If your kids are interested in physics and all that, it brings them right to a level where you can integrate your moments of inertia for your compound pendulum or whatever that your kids want to do also, right? So I usually tell kids that if you want to do physics, we'll learn pre-cal or calculus as soon as possible. Right? Hope that makes sense to you folks. But that's all I have, all right? So, so I thought maybe we'll open up the floor for any questions. You guys have anything, right? So this morning or this evening we talk about the maybe some of the math contests. We look at some of the math camps. We look at some of the typical classes you can have, in case you're not familiar with. So I thought maybe open up the floor for any questions. So, yes?
So my son is taking Algebra 2.
Right.
So is it possible that he can skip pre-cal and take the calculus next year?
It depends though, right? So everything is possible, right? I'll give you an example then. For example, Limbrook right now, you can take any class you want because they are kind of tired of parents.
But will it be very difficult?
It really depends on your kids' kind of background and preparation also, right? So I think it is on an individual level. If he's ready, right? So I'll tell you the subjects-wise between Algebra 2, Trig, and Pre-Cal, they're very similar.
Oh, very similar.
Very similar. They learn the same subject. It's usually Pre-Cal is more, maybe more advanced, more in-depth, but topic-wise, they're very, very similar.
I see.
Yeah, this all consider milk. Maybe, yeah. However, you have additional information, please.
Yeah, so it depends on which school you are going to. So, like for example, if Limbrook, that they changed the policy as he said, so there's no more placement tests. So if you, but you must take Algebra 1 and Geometry. That you have to take somewhere else and on your transcript. But beyond that, you can just skip it. But other high school is kind of difficult to just skip. Simply skipping is not that easy. So lots of students take accredited, taking a classes at accredited school. For example, taking a summer at like a MIT, St. Francis, Harvard, then you get the credit. Then you can accelerate your school class. Or some students take like online course, but that's accredited. Like for example, CTY, BYU. Yeah, so those it depends on the school you're going to.
So where is the spring light? Which kind of use?
You are at Spring
So you offer class here, right?
Yes.
I see.
It's kind of small, this room. Do you have other classroom?
Yeah, all our class are small classroom, small class, yeah. This room is the biggest classroom. Yeah.
So what's
Normally
your
all students is around the 10 students, so the maximum the 20 students. Sometimes only it's a small group of 4 students, 6 students, yeah.
Can a 6th grader take the AMCA? You think it should be okay, right?
I think so.
Yeah,
Definitely.
But the problems, I think you showed kind of like to be more difficult.
That's what they learn in the class. Those are problems we teach them. 6 weeks is perfect actually.
So do you think it will still be beneficial if a child is qualified AIME will take the ANC 10 or 12 here just to increase the performance of the ANC 10 or 12? Or you suggest skip 10 to 12?
I think
That'll be too fundamental.
I think for kids who are already qualified for AIME, but
Okay.
usually kids are kind of worried because usually it's very difficult to qualify AIME, and they worry maybe next year they don't get qualified for AIME. It's possible actually, right?
No, I don't think
If
it's
that's not the
situation.
case, I
It's,
really see no reason. And most kids on that level, once they qualify AIME, they usually the best way for them to learn is to do past problems.
Okay.
So some kids do a lot of past problems.
Okay.
That's the best way to
So
learn.
practice.
So the question I have is, so for kids they have limited time, for example, and so you want to AP, you want to contest,
Yeah.
so which probably make more sense to put more focus, and if with limited time.
I think definitely math.
Huh?
So math is a basic.
Yes.
So if you are doing really well, if you have a strong math basic, then it's easy to move on. You can do USACO. Have you heard of USACO? It's a USA Computer Olympiad. So and there's a F equals ma. This is a physics Olympiad. So you can see you can Google the names for those USAMO qualifier. There's everything. Names are listed. And the USACO semi-finalist names listed. Use the code, you can see the names too. Those students all overlapped because those students who have a strong math basic, they do really well. I mean, it's so easy to learn the next step.
Yeah, so my question is more about like you're doing AMC, doing
Oh, okay. I'm
doing
sorry.
again in the math context
Yeah, I think AMC
between
is
the
a,
AP and the
AMC is a basic one.
You have AP classes?
yeah.
Oh, that's
Oh,
different.
that's different, yeah.
Yeah.
But
Math AP or
if kids do well in math contests, I see no reason why they have to worry about AIME classes
Yeah, they don't.
in math. There's absolutely no reason, actually. Yeah. I've never seen a kid that have to worry about AP classes if they do well in math contests.
But if they don't do those math competition, more focused on the AP courses.
Oh, well, no question about that. The most important thing, keep a good GPA.
Yeah.
That definitely.
Yeah, that's the first thing.
Yeah, that's the
Okay,
first thing.
okay.
Definitely.
So for AMC 10, do you have any books that you recommend the kids to use to
Yeah.
prepare?
In spring break week, when we teach classes, we usually don't use a book. We use a set of books actually to expose the kids to multiple styles of questions actually. So myself, I don't know about other teachers here. For myself, I usually use some books. There's some American textbooks. I usually use some books from Singapore. So I have different sets of textbooks on that kind of problems actually. Because I want to mix and match different problems for the kids actually. Yes.
What's your calculus AP class? How is it different from calculus BC? How is it different from the class in school, like the Limbo class school?
We have fewer hours of delivery, so usually it's very condensed. So we usually go right to the point. Right. So we typically run something like maybe around a dozen or 15 classes only. We have to cover the whole curriculum. So it's very fast paced, but we are very to the point. So you can count on the fact that examples are very to the point, and of course we have homeworks too for the kids also.
So if my kid is already taking calculus BC at school,
Right.
is your class still beneficial to the kid?
Only if he does need any help from maybe. If he's not doing well, if he's lost in class, only then is it useful to take the class. Others no need.
Can I ask you what's the average age of your AMC 10 students in here? Like what's the youngest? Let's see. Grade wise, like fourth grade is too early.
Oh no, yeah.
Okay. This
You mean currently is the fourth grade?
yeah.
Fourth grade depends on the foundation.
Yeah.
The youngest here at the Springlight, we had the student is a fifth grade qualified AIME. Yeah, but that's very smart. The kids this year, so they're really smart. Yeah, so that kid when the mom several years ago asked me to join your class, I said no, I don't. Here only middle school and high school. She said, okay, please slow down. Yeah, listen to me. And different kids are different. So and then when I listen to her case, the boys' situation, I said, okay, welcome. Please join the class. Yeah. Yeah, the youngest case I talked. The sixth grader already took the calculus. Yeah, and then seventh grader already takes multivariable calculus. That's a case come from Sacramento. Yeah, he came here. The dad bring him here and said, "We looking for classes. We don't know what we can do. He just learn. And he takes a complete. There is a complete college. He doesn't care it's an age. Yeah, you just take the class." Yeah, they totally depend on the case. Yeah.
See, the nice thing is that when you're in middle school, you're not as busy as kids in high school. High school you're so busy. You don't want to mess up with your GPA and all that, right? So middle school is the best time to do this kind of stuff. Actually. So a lot of people do not realize. They say, oh yeah, maybe the middle school contest does not count towards the college admission and all that, right? But that's the time for you to prepare for all this actually. And it's true. Even though you might be qualified for something great in middle school, you don't really have a chance to put them in your in your college admission. But you can count on the fact that the kid's going to do well.
But the knowledge is, yeah.
And particularly, even elementary school kids also. There's really nothing that they are really learning much in elementary school. At least that's my experience.
Do you have tests for the kids to test which class they should go, like AMCA or 10 or AIME?
That's good, that's
Yeah. They want like a placement test.
Yeah.
Yeah, we can give the kids a placement test also.
Yeah, maybe first we can let the kid, we can ask several questions, and then we know which test we can give to him.
It's not that difficult, because you can ask a kid, do you know geometry, do you know binomial expansion? You can ask a kid, you already know what level they are on. Of course, they can say that yes, they do, until I give them the question. So.
Any more questions? No questions? Okay. Okay, so